Hello there, and welcome to our presentation for today called Transformations with Matrices. Matrices is the plural of matrix. Let's get started. So first, we need a little background. The first thing is an ordered pair, which is also meaning a coordinate pair. Usually we see this as x comma y inside parentheses, meaning the point x comma y, or sometimes it's labeled with a letter like pxy, meaning the point P, which is at those coordinates xy. All of these are points on the coordinate plane, which is also sometimes called the Cartesian plane with the x and y axes. For example, we can have the point T at negative 3, 2, which means the point T at x equals negative 3 and y equals 2, as shown by the red dot on this coordinate plane and labeled T. For matrices, we don't use the parentheses symbols. Instead, we write them usually with square brackets, and they're written vertically as opposed to left and right with the coordinate pair. So T of negative 3, 2 would become, in square brackets, negative 3 over 2 with the x value over the y value. The coordinates of the corners of this triangle can be written as a matrix that has 2 rows and 3 columns. So representing the points at the corners, negative 2, 1, x of negative 2 and y of 1, 3, 1, and 1, 6. The first transformation we're going to talk about is translation, and the easy word for this is slide. So let's move our triangle 2 units to the right and 3 units down. So this translation can be shown with the matrix of 2 over negative 3. So there it is. That new triangle is the after the translation. The new object comes from combining the two matrices of 2 over negative 3 with the matrices of the coordinates of the triangle, giving us the new triangle with corners at 0, negative 2, 5, negative 2, and 3, 3. For translation or sliding, we combine with a matrix that looks like this, of course, x over y, where x being greater than 0 means moving to the right, and less than 0 means moving it to the left. And a y value greater than 0 means moving up, and less than 0 means moving down. The second transformation we'll talk about is rotation, and the key word for this is turn. To learn about this, we first look at a model for rotation of I and j. So on this coordinate plane here, we can see I in the red, starting at the origin and finishing at the red dot, which is at the point 1, 0. And j in the green, starting at the origin and finishing at the red-green dot at the point 0, 1. And this gives us the IJ matrix of 1 over 0 and then 0 over 1. So for example, if we wanted to rotate 90 degrees counterclockwise, we redraw I and j to show this rotation as shown here. And now the I has the red dot finishing at 1, 0, and the green dot is at negative 1, 0, giving us a new matrix of 0 over 1 and negative 1 over 0. And we're going to use this matrix to do our rotation. So here we have our triangle again, and we brought along our IJ matrix showing a rotation of 90 degrees counterclockwise. We'll multiply these together. So let's look a little bit at matrix multiplication. So here we have I and j times the 2 by 3 matrix, which are the coordinates of the triangle, giving us something I've labeled as A, B, C, D, E, F. So how does it work? So first, the A value in the answer comes from multiplying the first row of ij times the first column of the coordinates of the triangle, then adding those together to give one value, which would be the value for A. So there we see A is circled, the first row of ij multiplied by the values in the first column of the triangle and then added together, giving -1. The B value for the pair of AB comes from multiplying the second row of the ij matrix times still the first column of the coordinates of the triangle, then adding them together. So this gives us a total of -2. So this continues on for C, D, E, and F, multiplying the first row of I and j to give us the values for A, C, and E, and multiplying the second row of I and j to give us the values of B, D, and F, going through the columns of the triangle matrix, starting from left to right, the first column, the second column, and the third column. So let's see this happen. I've shown the matrix here, I and j again, along with the coordinates of the triangle. I've also made the vertices of the triangle different colors of pink, green, and blue, so that the rotation is clearer to see. So there are our answers, -1 over -2, -1 over 3, and -6 over 1 from the last slide. And you can see the triangle has been rotated by 90 degrees counterclockwise. By adjusting the I and j matrix, you can perform a rotation to a quarter turn stopping point either clockwise or counterclockwise. In other words, the rotation by 90 degrees, 180 degrees, 270, or 360 degrees. All of these are multiples of 90. 360 would basically put you back where you started from, so that's the story of that. Now, in addition, to do a rotation of another angle size, not in the multiple of 90s, you would create the I and j matrix as follows, with one for counterclockwise and one for clockwise, using sine and cosine functions of the angle, where the theta symbol is the angle measurement. But this is beyond the scope of this presentation, but feel free to try it yourself with your calculator. The third transformation we'll talk about is reflection. The easy word for this is flip. To do this, you'll also use I and j. You can flip I and j to discover the matrix to use to do your reflection. Here are some common ones though. We have one for reflecting in the x-axis, another one for reflecting in the y-axis, one for reflecting in the line y equals x, and one for reflecting the line y equals -x. There's also one for reflecting about the origin. The final transformation we'll talk about is enlargement, which is also sometimes called dilation. To do this, we'll also again use I and j. The first situation is enlargement about the center or origin at the point 0, 0. By using the I and j matrix of k over 0 and 0 over k, with a value k greater than 1, it will mean increasing the size. For example, a value k will mean that it doubles in size. For a value of k between 0 and 1, a fractional value, such as 0.5 or 1/2, this would mean making it smaller, for example, smaller by half. The second situation is enlargement or dilation with the center at AB. let's say you have the triangle to work with, our favorite triangle now. So we have the I and J matrix with k over 0, 0 over k, times the coordinates of the vertices of the triangle. But we notice we're subtracting the a value. So where we want to center it at, we're subtracting a from the first row of the triangle coordinates, subtracting it from -2, 3, and 1. And also, for the second row of the triangle coordinates, we're subtracting the b value from 1, 1, and 6. Then this result of the subtractions would then be multiplied by the IJ matrix. And finally, the results of that would be added to A and B, just as in a similar way we had done the translation at the very beginning. So the results after the multiplication have A over B added to them. That's it. I hope you learned a little bit about matrices and transformation. Thanks very much. Bye.